You're able to see this okay?
Great.
All right, so I'm Simon. I'm the co-founder CTO of Proxy, and as Chris said, I'll talk a little bit about what's it like to build a product today using one of these as opposed to sometime in the future. Firstly, who we are at Proxy. We've been a hardware plus software company for a while. We started in the physical access space where we were building NFC reader hardware, Bluetooth reader hardware, wearables, and phone wallets, so they put in quotes, but phone apps for enterprise physical access control. Think employee badges for getting through doors, as well as logging in within your workplace and booking meeting rooms and things like that. We pretty much pushed the mobile version of this into this physical security industry when we started. It has been sort of an afterthought when we got into this, and we made this a first-class citizen. Worked with a couple of phone manufacturers to make this a reality in Apple Wallet, for example, and also involved in standardizing some of these protocols to make them more universal. CSA, former Zigbee Alliance is leading the way there. So what are we building right now that's relevant here? To some extent, the access control stuff is our legacy as a company, but one of the things that we found is that there's a bigger need there for managing digital credentials and digital identity that isn't just for access credentials, but any sort of credentials, and it fits very nicely into the world that the cryptocurrency community has created. So what we're building today is a wearable hardware wallet and a complementary mobile-based software wallet that's an evolution of our previous Proxy app that will cover more of the digital identity use cases, as well as crypto asset storage. And we see this as very complementary. Ideally, this is creating a single product where software and hardware are working together to give you a better experience, which has always been our sort of our motto as a company, is getting those two to work nicely together. So I mentioned wearable hardware, obviously some very unique challenges that some of the other manufacturers don't run into. Extremely limited battery power, extremely limited physical space, where the form factor we're talking about here is a ring. So it's probably smaller than you imagine. Limited I/O capabilities. To some extent, that's actually to our advantage here, because we sidestep some of the secure UI problems that Mark has mentioned in his presentation. We kind of don't have a lot of I/O. You have secure radio access through NFC that's directly bound to the secure element, and that's about the only I/O we have, but it's also the only secure I/O we have. And lastly, sort of being so limited in space and power, we're working with a very high degree of integration. We're not dealing with discrete components a lot of the time, like a separate secure element, a separate NFC front end. We're talking about multi-chip packages, which are as highly integrated as possible to save on space, save on power, save on routing area on the circuit boards, which of course results in very few options for us to choose from, because we're limited to what integrated solutions are already available and can't necessarily pick and choose the best of class for each individual component. Lastly, as a wearable device, there's certain what I call table stakes. We're not building a single purpose device, because as a wearable, it has to do all the things people expect it to do. It would be pretty difficult to convince people to wear 10 rings or glasses or wristbands, where one of them is your mobile driver's license, and one of them has your Bitcoins, and one of them you use to access the door, and you forget which finger is which. So this is the same sort of category of devices as something like a phone or a watch, where it has to be fairly multi-purpose, and it has to work with things that people already use today, which kind of gets me to this real world or real live usage conversation. There was a nice article, and I'll paste a link to this in the chat in a little bit, which talked about the proliferation of crypto wallets and sort of which direction that stuff is going. And they focused on this equation of user experience, which kind of represents the convenience and the quality of that experience, crossed with the level of integration with existing systems, and a good enough by default level of security that will actually make a wallet, whether it's a software wallet or hardware wallet, that actually reaches mass adoption and brings some of these use cases to the masses, so to say. And that's exactly when I read that, this is exactly the sort of thing that we at Proxy are focused on, and that's essentially spot on how we think about things and what we're building. So I've listed here some of the things that people use already today with various hardware devices, cards, hardware tokens, badges, phones, etc. And these are the sort of use cases that we have to support in addition to talking about cryptocurrencies if we want to build a multi-purpose device. And of course, always be aware that there's both existing legacy and new terminal infrastructure that's being deployed. Coming from the physical access control, we're very acutely aware of the importance of interop with that existing infrastructure, because we're talking about devices which hang on office doors for decades, and we've been involved in building and deploying some of those devices. But those things are not getting replaced. And if you think you're gonna switch how people do things by getting everyone to install new terminals, then you're probably fooling yourself. So some of the challenges that I've seen sort of firsthand trying to design a product that does at least some subset of these things. Limited functionality on existing secure elements. Mark kind of touched on this a little bit, with a lot of them being black boxes. There are some which are somewhat open, but they are primarily Java card-based runtime environments. And that's because that's where most of the applications are today. A lot of the things I have on the previous slide, like payments, transit, access control, have existing Java card applications built for those secure elements. And that's a somewhat specialized runtime environment with persistent memory and other things like that. There's the new curves. They're not new by sort of any stretch of imagination, but in this context, they are new, which are required for a lot of the cryptocurrency stuff, which currently don't exist. New algorithms, signatures, ciphers, these things are popping up much faster than they used to, and they're being much more widely adopted faster than they used to. So in many ways, the hardware vendors are chasing this rapidly moving target. As Mark kind of alluded to, the timelines along there, it takes years to develop a new chip and huge capital cost. And by the time you're done, it's already obsolete, because you have things like mobile driver's license ISO standard that literally just got published last year, and it's 150 pages of a really complex standard that probably can't run on 99% of the secure element chips on the market today, because it supports selective disclosure. It has fairly complicated parsing and signature logic, and things like that. So I think other people in this room are better equipped to talk about the specifics of the ciphers and the signatures which are involved in this, the various side channel attacks. But lack of these things and lack of visibility of these things as well is one of the major problems. The next one is something that I see being caused specifically by the certification requirements. For existing applications, again, things like payments, access control, there's costly, lengthy certification processes in Vico, Global Platform, MasterCard, Visa, transport networks, which cost a lot, and they end up freezing your entire stack so that you can't change a single thing. And that leads to fairly predictable market dynamics where a vendor isn't going to change anything for you that's going to retrigger a certification process unless they already have a large commitment from a big player, like a phone manufacturer or someone that actually wants that functionality. It's not necessarily a problem of the specs and the standards not being there. It's unwillingness to implement them quickly because of those market dynamics. Java Cut 3.1 has been around for a couple of years. I haven't seen a single secure element chip that actually implements it at this point. Nobody's done it yet. And even 3.05, which is 7 years old now, isn't that commonly adopted. There's so many mass market secure element chips out there that are still stuck on 3.03, 3.04 API versions. And just as one example, I just pulled this one up randomly. There's an NXP chip that has added AES-GCM support just at the start of this year. And that's brand new silicon before a small player like Proxy can use this in a new product design. That silicon needs to get to volume production. It needs to become available enough for us to actually buy and use, because we're not buying hundreds of millions of them, we're buying thousands. So it's quite far behind. You'll hear Christopher probably say that AES-GCM is already deprecated, and yet it's only made it into this piece of silicon this year. And the last sort of challenge I want to talk about is lack of kind of single point of view from any one of these manufacturers or vendors that often make these chips today. Quite often, the entire spectrum of expertise doesn't exist in-house. The chip vendors are specialized at making the silicon or integrating pieces of silicon into a multi-chip package. Sometimes they're RF experts, sometimes they're silicon manufacturing experts or memory experts, like we heard from Mark. But they may not have the software expertise, and that's often outsourced. The security is often outsourced, or vice versa. You have software houses that are buying these chips off the shelf and hoping to build a product using them, but they don't have a lot of influence on what goes into the hardware, and they're kind of using it as a black box. And one of the big problems with this that I see is that the people who are making the major components for some of these products are not the people who are making the products. So there's a disconnect between what the product requirements are and what the components can do, because there's not that tight feedback loop. Personally, I come from software world, and looking at a lot of the software packages that have become hugely successful recently, the various data store implementations and things like React. So many of those have evolved from a product company solving their own problem, be it Facebook or Google or someone else solving a problem that they have, and then open sourcing a piece of infrastructure code or a framework that allowed them to solve that product problem. And other people have the same product problem, and they use it. But that component evolved out of a product need. That doesn't happen with hardware chips, because the people making the hardware are not also making the products. So one of the things I'm hoping to get out of this is that closer integration there. And hopefully that leads to more information sharing as well. Yeah, and just a couple of thoughts on what would help things. Finding ways to build architectures where some of the existing applications can coexist with some of the new stuff being developed by crypto wallets, for example. We, again, just going back to our requirements, we don't have the luxury of a single function device, like a ledger that you plug in and use and then put in a safe. We need to support the existing applications as well as the new stuff we want to build. We can't just ignore the fact that everything runs on Java card. If integrated solutions are being developed like multi-chip packages, they should be developed with high level of flexibility and modularity. So that as a consumer of that package, we can pick and choose when to enable certain things, when not to enable certain things. And I realized from a hardware manufacturer perspective, that of course adds costs. That's more pins, more routing, more switching logic, but it'll make that silicon more worthwhile to actually produce long-term, per Mark's point earlier as well, where if we align those requirements and make that hardware more useful in more use cases, it'll make for a longer lasting chip than just locking it down to a single purpose like credit card payments. And then figuring out a way where some of these things can move faster than others. You'll probably hear a lot of this, but and I've mentioned this with certifications, but some of these things need to move slowly for good reasons. But at the same time, you don't want that to be the limiting factor. You want parts of the system which can evolve faster, have the ability to do so. So that pretty much covers what I wanted to talk about, and what I'm hoping to discuss in the Q&A sessions later as well. But yeah, I'm of course available for other questions or conversations. More than happy to have more of these.
Great, thank you, Simon.